Here is a BMG 6 volts camping lantern. I'm not familiar with the BMG, or is it RMG? I don't even know. It's American made. There's the patent information. It looks like at some point it had some corroding battery in there, probably a door cell. Bulb replacement used number 1651. Battery replacement used 6 volt with coil spring terminals. I have a good number of these camping lanterns. While I'm not really a camping person, I do like to use these out in the yard at night. Usually on the deck. I'll put one of these on the table if I'm eating dinner outside and it's completely dark or something. Sometimes I use them in the house too. I thought this was interesting because this one seems like it's significantly older and perhaps higher end than some of the other ones that I have. A bunch of the ones I have are from like the 2000s era. They have the red base and just a cheesy slide switch on them. This one has, I don't know if this was originally this color. If it's yellowed, it's done so pretty evenly. Oh, nicer color base, some brown trim on there, and it's got a push button control, which is kind of interesting. Shade is made of very thick plastic. It is slightly busted up there, but we can probably glue that into place very easily. Here is the bulb. I don't know if the bulb still works or not. I have not tested it yet. I believe these are just more or less like automotive bulbs. I don't think there's anything special about these. It's very, very dusty. It's definitely been in there for a while. It says 1651. It says 1651. It looks like it says 5 volts and 0.6 amps. Taiwan. That was interesting that it's a 5 volt with the battery at 6. That's particularly interesting because the way that I operate these is with something like this. So what this is it's a D-cell to lantern battery form factor adapter. The lantern batteries have become very expensive in recent times. I feel like they're probably just going to go extinct sooner or later, and they're single use. So for my use case where I just use one of these casually for no reason, it's totally impractical. So I got a bunch of these, and then I can use them with rechargeable nickel metal hydride or nickel cadmium batteries, D-cell or D-size batteries. So these are made in China batteries, the Ray Hom brand. I've had these for several years, and for whatever it's worth, they seem like they're working just fine still. I don't think they work quite as good as they used to, but generally speaking, they still work pretty well. Now, regular like alkaline batteries, for example, output 1.5 volts per unit, whereas these nickel metal hydride and nickel cadmium only output 1.2 volts for a cell. And I have no idea why that is. We would probably need a chemist or an electrical engineer to explain why the cells output the voltage that they do. But when we add all this together, 1.2 and 1.2 is 2.4, and 2.4 times 2 pairs gives us 4.6, which is almost, no, that's not right, it's 4.8, 4.8 volts, which is almost 5, so that's right around what the bulb actually calls for, whereas a lantern battery would output 6 versus 4.8. So I suppose what's done to get a little more brightness out of it is the bulb is slightly overvolted. Although actually, when you think about it, a 5 volt rating running on 6 volts, even though that's only a 1 volt difference, that's an astronomical difference. That's a fifth of a difference. That's a huge variance. So that would probably decrease the lifespan of the bulb substantially, though I suppose in a case like this, it probably doesn't matter that much because this is not something that's likely to run a high number of hours. So let's stick this in here and we'll turn this on. This is what the battery compartment looks like on the inside. Fortunately, there does not appear to be any evidence of leakage on the terminal area, just on the bottom of the cap there. I'm not going to put the cap on because I don't want to get the battery corrosion all over there, so we'll need to clean that off. This fits on very easily. This goes on easily, that goes in and out easily. Sometimes you got to screw the cap on and it doesn't fit the greatest and so forth. So this is really nice. I like this. Well, unfortunately, it doesn't seem to work. I wonder if the bulb is just spoiled. Or am I not getting this on there properly? I'm not getting it on there properly. Alright, I guess I'm going to have to put the cover on. Let's wipe off any loose corrosion. I don't... yeah, actually there is a lot of corrosion coming off of there. I should probably clean this out with isopropyl, or the heck it is, alcohol. But I think that's good enough for the test. Okay. The switch might need some deoxidizing as well. It seemed a little dodgy. Now this bulb is different than some of the other ones I've seen. A lot of the ones I have are clear, whereas this one is frosted. I would not choose a frosted bulb in this application because you're going to lose some of the brightness. See, it's a little bit dodgy if I hit the switch at all. That was pretty standard in terms of light output. It's daylight right now, so I can't get the studio really dark enough to tell, but you can see it casting a shadow on the bench and everything, so it is lighting up pretty well. And of course, being incandescent, quality of light is exactly the way that it should be. Another interesting item about the battery voltage, I use these nickel metal hydride batteries in there, and I really don't notice too much of a difference in terms of runtime. And I think it's because, although I think in theory an alkaline battery should last longer in terms of hours of operation, but the voltage drop of an alkaline battery, the graph is pretty constant. So like after 2 minutes of operation, it might be at 99% capacity, and it might also be only at 1.45 volts instead of 1.5. And the voltage drops very quickly as the battery runs out of charge, whereas with the nickel metal hydride battery and also with nickel cadmium, and this is why they were chosen for use with electronics a lot years ago, the voltage drop is much more gradual when it's at higher levels of charge and initially discharging. I don't recall off the top of my dome what the graph actually looks like, but I think it's somewhere, I don't know, at least like I would say down to like 30 or 40% charge. it maintains the majority of its voltage, and then it starts to drop off. So the flashlight battery, the lantern battery, conventional alkaline style, might give you a longer runtime, but I think that the light would stay brighter for longer with the nickel metal hydrides.